Question 6. Good old straight line. So, what have we got here? Well, we've just got a graph, and part A is telling us to find the equation of the line of best fit. Doesn't really matter if it's the best fit, it's still a line, in terms of key point F and E. Now, why is it telling us in terms of F and E? Well, this creator has decided to replace the x-axis, they've called that E, and the y-axis, they've called that F. So that's where they're getting their E and F from. So, how do we find the equation of a straight line? Well, we need a couple of things. We need the gradient. I'd recommend writing, if it helps you in the exam, you can write a little checklist for yourself and check as it goes. Check it off as it goes along, because these questions can sometimes get quite complicated, or you can lose track. So, point on the line, anyone you want, and then we also need the formula for a straight line. In this case, I'll be using y minus b equals m bracket x minus a, which has been permanently ingrained into my brain. So, part A, I think we should do the gradient first. And actually, I'll pick a different colour. Gradient. So, formula for gradient. First of all, let's find our points. Now, it's quite obvious which points we should use, because they're the ones that can be identified. Here and here. So what is this point? Well, we are 3.5 on the x and 8 on the y. And for this point, we are 1.5 on the x and 14 on the y. So I like to draw myself this little grid, shall we say. So I'll put my point 3.5, 8, and 1.5, 14. Now I like to label this to just remind myself. So this is x and this is y. And just a quick aside, although we're finding it in terms of f and e, and this is all being replaced, just work through it in x and y, and then you can change it to in terms of f and e at the end, because you'll be used to working it in x and y, and it's just more comfortable and familiar, and it should, I think, reduce the likelihood of you making a mistake. So then also I know that I need to label these 1 and 2, so I'm going to be strategic, and well, actually you could really just label anyone you want, really. So let's call this 1 and 2. So our formula for the gradient is m equals y2 minus y1 over x2 minus x1. What is y2? Well, we can go to our little chart that we created, and we can find y2. We find y, which is 14, and then go across as 2. So that'd be 14 minus 8. And this would be 1.5 minus 3.5. So 14 minus 8 is 6. 1.5 minus 3.5 is negative 2. So this could be written as negative 6 over 2, or equivalent, which is also negative 6 divided by 2 is also negative 3. So this is good. This is a auspicious sign, guys, because this line here is going down. So the negative should be gradient. So the gradient should be negative. So if you had a positive here, I would be concerned, and I would go back and check your substitution, because it's quite easy, especially in here, to make a mistake. So now we've got our gradients. We just need to choose a point on the line. We need that for our equation as well. So you can just choose any point you want. I'm probably just going to choose 0.2. So I would rewrite this in terms of m. Oh, yellow is not a good colour, is it? Let's go for a green. M. So I know m is equal to, why is there a, here we go. M is equal to negative 3. A. So I'm going to have to write my point as well in here. So negative, 1.5, 14. I'm going to label this A and B. You need to label it because we're about to use this, and A and B, your marker doesn't know what A and B are. It could be anything. So, y minus b equals in bracket x minus a. Y minus b, here, 14, equals m, negative 3, x minus a, which is equal to negative 1.5. Y minus 14 is equal to negative 3 times x is negative 3. X, negative, watch out for this, negative times a negative is positive, so that'll be plus 4.5. We take this negative 14 across, which means we do the opposite and we add to both sides. Y is equal to negative 3x plus 18.5. Excellent, so we've got that, but don't forget guys, they wanted it in terms of f and e, because there are no x's and y's in this thing. So then we just rewrite that. So we know that our x is an e and our y is an f. So f is equal to negative 3 e plus 18.5. And voila! That is your answer. So, common mistakes, just be careful when you're substituting stuff in. Be careful of any negatives here and here. Make sure you communicate what points you're using. And don't panic if you see this. Yep, communication here and here as well, just to make it explicit what you're using for that. And if you find a little tick list helpful like I do, I forgot to do it whilst I was going along, but you can just tick it off as you go, like that. Now on to part B. So it's telling us to use our equation, which is this, to estimate how many kilometres per litre a mar should expect to get. Now, this, we need to read the graph here. So the scatter graph shows the relationship between the fuel consumption, F kilometres per litre, and the engine size, E litres of the cars. So what are we told about a mar? Well, we're told his engine size. So if we're told his engine size, we've been told an X value. So we know that a mar's engine size is somewhere 1.1, that's probably like here on the x-axis. And we're being asked to estimate how many kilometres per litre he should expect to get. What's kilometres per litre? The y-axis. So we're given the x and we're asked to find the y. The y is the f. But we can do this, guys, because we've just come up with our little thing. Because we have everything. We're asked to find this, and we have all the values for this, because we only have one unknown. So, using that, we can do this. And rather big writing, I must add. 18.5 f is equal to, okay, so his x here, which is turned into e, is 1.1. Negative 3 times 1.1 plus 18.5 f is equal to negative 3.3 plus 18.5 f is equal to, actually, quick tip, the way I would do this is I would actually do 18.5 take away 3.3, which I know is 15.2. You can do that because I know it's going to be positive. So, a mar should expect to get, I would just probably write a sentence here actually. A mar should expect to get 15.2 kilometres per litre. That's your answer. So what we did there is we just used our equation from here, and we made sure I tried to explain that actually you're like, oh, I don't know a mar's kilometres per litre. Well, you do, because it's in the graph, and you just need to think in terms of x and y.
pull back that curtain of context and you'll be a winner. Thanks for watching, everyone.